Thank you. So, what is software design? Is this design? Is this design? Well, obviously not. So, let's go to the supreme authority and ask Wikipedia what design is. So Wikipedia says that software design is the process of implementing software solutions to one or set of problems. One of the important parts of software design is blah, 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 blah. That's hardly helpful. So I think that we have a problem understanding what design is and what it isn't. And we're still using methodologies and ideas from an era of before Agile, of waterfall development, of deliverable systems, like hard copy deliverable systems. We're not thinking about our software as something that is evolutionary. And by doing that, we're not building software that is adaptive or resilient to change. And in this day, software always changes. Software changes continuously. I work at Wix.com. Wix.com is an internet platform for building websites. So it's a website that allows you to build websites. And we deliver software continuously. We use continuous delivery. We deliver software, multiple times a day. Our statistics say that every 8 minutes something changes in our production systems. You cannot have a system that is not adaptive to change with this scale. So today I'm going to talk to you about stuff that I learned in the past 10 or 11 years that I've been doing software, and in the past 6 years that I've been at Wix. But before that, I want to ask you, how many of you are testers? How many of you practice TDD? How many of you write code for a living? How many of you have been to Noam's talk earlier about emergent design? Okay, good. So a lot of the things that we talk about overlap or resonate with each other, but we have different takes on the same idea. So it's good. I think that TDD can help you become a better software engineer. And I think that TDD can help you reduce the frustration that you have from maintaining software systems for a long time. And we all know that most of the effort that we spend in software is on maintaining software and not on writing the software itself. I think that basically the concept of software engineering is a bit misleading because we're not software engineers. Our job is not like the job of someone who builds a bridge or a car, because a bridge is built once and then they maintain it, they replace parts maybe, but they don't change the bridge's design over time. Whereas software changes all of the time. So a better analogy would be that we are software gardeners. We design gardens. Now that doesn't sit very well with our traditional definition of design, because when we think about design, we usually think about design documents, diagrams, about those architects who write those things and then hand off the architecture for a team of monkeys to come along and code, implement the design. But this concept is a bit outdated in my opinion. Who's heard of this book? Bruce? Awesome book. I highly recommend it. At Wix, we hand over a hard copy. We give away a hard copy of this book to every new employee, every new software engineer, because we believe so much about its message. And basically, in Goose, Enterprise and Tillman say that software is like gardening. There's a growing aspect of software. And I really like this analogy, because think about humans. We've been around for, 2 million years or so, but we've been like gardeners or agriculturers for about 10,000 years. And we have a history of taking wild plants and adapting them to our needs. We took wild cabbage and we made it into broccoli and cauliflower and cabbage and Brussels sprouts and kale and whatnot. But it's all the same plant initially. And software is very similar. You almost always start with something that exists and you grow it. You almost never have a greenfield project. And even if you do have a greenfield project, a month in, it's no longer greenfield. You already have something existing that you need to grow. So we need to take two concepts and merge them together. One is of the software engineering, and the other is software gardening. And Michael Feathers said that the problem is that we have a wrong definition of what it means to be a software engineer. And again, talking about a bridge, that the concept, the general opinion is that an engineer draws a diagram or creates a blueprint, and then there's a manufacturing team that builds the actual bridge. And in software, we also always thought that there was this software architect who writes the documents and draws diagrams and hands off UMLs, and then there's a team of implementers who come in and write the code. And that these blueprints are the design, and then the coders actually do the work. But this is incorrect, because what actually happens is that we, the coders, we are the designers, we are the architects, and the manufacturing team is the compiler or the interpreter. It's what takes our code and turns it into actual deliverable or runnable software. So basically what I'm saying is that to code is to design. And as we grow our software evolutionary, the design emerges. We have the idea of emergent design in software. And that idea is very strong, because emergent design is what helps us deal with changes over time. Because that design is not tied down to any presumption that we have about our software. Now, unfortunately, software grows with or without our interference. We're not always the only person that is involved in the project, and the requirements will change. And our job is to water and fertilize and trim and prune our software system. Otherwise, just like a plant, it might rot. It might become, I'm not seeing this, and I have a internet connection. Oh yeah, install Java. Thank you, Java. Thank you, Oracle. So, they're not sponsors, right? No. So, you're not seeing this, I guess. Oh yeah, you are. Okay, good. If you do not pay attention, our software becomes a big ball of mud. Who knows what a big ball of mud is? So a big ball of mud is a software system that has lost all design. It has grown over the years, usually a lot of years. Can you shut the door, please? No? Oh. So it has grown for so long and so big that it can no longer accumulate all of the changes that are needed from it. So it has lost all design. So when a developer attempts to take a new requirement and apply it, she no longer even tries to design it. She just sticks it wherever it will fit and forgets about it. Now, some very successful software projects are big balls of mud, but it's very difficult to maintain them. So basically what I'm saying is that we need to make an assumption that the requirements of a software system will change. And sometimes it might change drastically. Many software systems are completely different from where they began. Now, we know that decisions that we make early on in the development stage have bigger impact on the development than later decisions. Very much like if you take the biological metaphor, a mutation, when it happens in an embryo in the womb, it has much bigger effect than the same mutation if it happens in someone who is 30 years old, for instance. So logic says that we should defer the bigger, the decisions that have more implication to a later stage of the system, and focus first on the interfaces of the system, of what we need to do, not how we want to implement it. So now I would like to convince you that although you have a lot of experience, you might have a lot of experience in writing software, in design patterns and technologies, that same experience makes you vulnerable, because that same experience will create blind spots. It has a tendency and it's human nature to follow familiar patterns and not think about what we need to do. we will often try to fit in. Again, Oracle. We will often try to fit in our current knowledge and force it on the problem at hand. And that's a problem. I grew up as a software engineer reading the Gang of Four book and using Spring Framework and Hibernate. They were really very hot in the last decade when I started to write software. And these concepts introduced by Spring and Hibernate, the ORM thing, they really shaped how I thought about software. And I found myself taking whatever problem was at hand and forcing it into the pigeonhole of ORM and Spring. And that was a mistake. As engineers, as technical people, we have a lot of experience and we have a lot of pride in that experience, but this pride can cloud our judgment. We have an ego problem, and we need to find a way to solve that ego problem. How do you do that? How do you set aside your experience? So basically, the problem is that we often write software that we don't need. Okay? For instance, I have to write a simple library system. I need to be able to lend a book to a reader. So how am I going to implement it? So I'm going to use Spring Framework, Spring MVC. So I'm going to have a book controller, and that book controller is going to have a lend book call, and that is going to talk to a book service because we need a service to embody everything that has to do with the book. And that book service is going to talk to a book DAO, data access object, that's going to talk to a database, and it's going to have a create book method and an update book method and a read book method and a find all books by author method. And do I need any of these right now? Well, what I need right now is the ability to lend a book to a reader. I don't need all of this extra stuff. All of this extra stuff is mechanics, is technology. It's not stuff that has anything to do with the problem that I need to solve. And this is a sin that we have as software engineers. We have a tendency to focus on the technological aspect because it's the cool aspect, and not on the semantic aspect, which is what we get paid for. And this is a problem. And one of the biggest sinners is naming. As soon as I think about a book service, automatically my mind goes into that place of an n-tier application that has one service for each domain object that embedded everything that has to do with that domain object. This is wrong. But if I called my service, my class, a librarian, then I would think that a librarian has to do stuff that deals with lending books to readers, maybe cataloging books also. But I'm framing myself. I'm creating an abstract language that defines the problem domain. And this language is what helps me in the direction of emerging my design. I think that as software engineers, our job is not to write code. Our job is to introduce abstractions. It's much more important. When your code does not violate the Yallin principle, when your code doesn't have anything that it doesn't need right now, it's much easier to spot stuff that doesn't belong there. It's much easier to introduce the abstractions that we need to introduce. Ugly pieces of code that don't belong there will automatically, jump out. If you have a librarian and suddenly in the librarian you have stuff that doesn't have to do with the job of a librarian, then it will be very clear to you that you need to move it elsewhere. So this is basically our job. Unfortunately, as we grew up as engineers, we adopted design pattern tainted glasses, and these glasses make it really hard for us to see the problem without automatically thinking about how we're going to implement it. Design patterns are solutions to problems. Design patterns are not first-class citizens of design. They are tools. That there's a very overused saying that when you have a hammer, everything looks like a nail, blah, blah, blah. I don't like it, but the concept is that when you have a visitor, everything looks like a visitee. When you have X design patterns in your mind, you will tend to only think in the terms of these design patterns. And we need a paradigm shift. We need something to help us shake off these old habits, to remove the patterns, the design pattern tainted glasses. So one solution to this problem is outside-in development. But basically, outside-in development says you write code from the outside. I want to write function first. I use that function. The code doesn't run, doesn't compile, or doesn't run, or whatever, and only then I write the function. When I do that, I'm automatically coding to interfaces and not to implementations. So if I always code from the outside in, I will never violate the Yallin principle, because I will never write code that I don't need. How do you do that? How do you do outside-in development? It's really not natural for us as engineers to do that, because we always like to jump a few steps ahead and prepare stuff that we're going to need later. Well, you're not going to need it later. What you might need later is not what you think now that you're going to need later anyway. So just don't do that. So how do you do outside-in development? Well, basically, you like a sculptor. You take, or like an onion. You have an onion over there, but like a sculptor. If you're a sculptor, you want to take a big block of marble and a hammer and a chisel and you start carving into it. And you carve into it from the outside in. And something emerges, something beautiful emerges. And what emerges in the case of a software system is our technological stack. We write a completely new system from the outside in. We do that very, very slowly and very, very carefully and without violating the Yallin principle. And what we end up is technological stack. Now that stack might be, a Java, MySQL, Linux system. It might be just a couple of JavaScript classes. It doesn't matter. The principle stays the same. But, again, it's not easy to do that. It's not easy to do outside-in development because it takes some patience. It takes some discipline to do that. And one way to do that, to achieve that discipline, is to cultivate a beginner's mind. When you're a beginner, you don't know anything. For instance, if I'm starting to take guitar lessons, I don't know anything about playing guitar. So I'm not going to have any assumption that I'm good at this. So I'm going to approach it with a very clear mind. But after a month or two, I'm going to think that I'm Slash. And I'm going to start, doing stuff that I can't do anymore. And does anyone know who Slash is anymore? Yeah. But I'm gonna have overconfidence, and I'm gonna have problems with that because it's really gonna hurt my performance. One of the biggest problems with people who are learning stuff is thinking that they know too much about what to do. And a beginner's mind is a way, an approach, Buddhist in origin, to always think of yourself as a beginner. Even if you've been doing this for 20 years, you cultivate a mindset of a beginner. So you're not making any assumptions. So you're letting yourself, surprising yourself. You're letting reality surprise you. And this really helps with the problem of design patterns and glasses. It really helps with the problem of pride. Because as soon as you're a beginner, you don't have any pride, you don't have any ego. You're thinking about stuff and you every day. And if you do that, then it's very easy to do outside-in development because outside-in development requires you to think like a newcomer to your system. You don't jump ahead. You always hold yourself back from making extreme changes. You're making small changes. How do you do that? How do you cultivate a beginner's mind as a software engineer? Well, this is where TDD comes in. I've been doing TDD for the past 4 or 5 years, I think. But before we talk about what TDD is, we need to talk about what TDD isn't, because it took me a while to understand what TDD is and isn't. So let's go quickly over these bullets. The first bullet, writing tests after writing production code. If you do that, then you're not doing TDD. I think everyone agrees to that by now. Well, maybe THH doesn't, but who cares? The opposite, writing all tests and only then writing the module or class or whatever is also wrong for the exact same reasons. You're actually violating Yagni. You're writing tests where you have no evidence that you need these tests. Third one, writing a lot of end-to-end tests for a system, and these end-to-end tests tend to be tightly coupled to the system's behavior. Now, you see that in systems where it's very easy to write these tests to bootstrap a system, like Rails, like Angular, modern web frameworks are very easy. It's very easy to write end-to-end tests with them, so it's very easy to make this mistake and have a lot of end-to-end tests. Now, this is a problem for multiple reasons. The first being that they run slowly, much, much slower than unit tests, and more importantly, because you have a lot of tests doing the same thing. A lot of tests running through the same setup, for instance. And then, when something changes in your system, in an underlying layer, a lot of things might break. So one change might break a lot of end-to-end tests. And this is a smell. This is a code smell that says that you have a problem of separation of concerns in your end-to-end tests. So a good system has few end-to-end tests that are not tied down to any specific implementation detail of the system. Finally, a mistake that we've been doing at Wix for a long time now is writing end-to-end tests that do not include one end or the other end. For instance, you have an end-to-end test for a server. Well, that's nice, but if the test doesn't include the clients that use that server, these are not end-to-end tests. These are system tests, component tests, whatever, acceptance tests, and they're perfectly fine, but they are not end-to-end tests. And if you call them end-to-end tests, then you are giving yourself false assurances, false confidence, because you don't have any confidence that the entire system works. You can change the server, you change your test, you change the server, you don't change the client that actually uses the server, the system breaks, you don't know that it breaks. So we've been doing TDD at Wix for the past 5 years or so. I joined the company in 2010, and I started maintaining a system called the public server. Now the public server, again, Wix is a website hosting platform, and the public server is what serves these websites to our users' users. So a Wix user builds a website, and their users visit the sites. So the public server serves these sites to the end users. It's a very important system. If it breaks, none of our 90 million sites can be served. And when I got that system, it was a big ball of mud. It had one class, one Spring MVC controller that has 3,000 lines of code in the same function, the do get function or whatnot. And you couldn't understand for the life of you how it worked. You couldn't follow the logical flow because there wasn't any. Because it started as something simple and then it grew because additional changes came in and no one could understand what it does anymore. So we started a refactoring project. We started to write end-to-end tests, but not end-to-end tests, like component tests. We call them end-to-end tests, but they were actually component tests that exercise that system from the outside. And then we could start refactoring from the outside in. And it took us a few months, but after these few months have passed, we had the entire logic of the system working as covered by unit tests that ran like this. That was a very good thing, because prior to that, it was very, very hard for us to make changes to the public server. We used to employ what I called prayer-driven development, where you would deploy something to production and you hoped that it worked, and often it didn't. And then if you have a downtime in a system that serves your most important assets to the users, then you're losing money. And you have a PR problem, and that's very bad. So TDD was good, so we started to adopt TDD. But it wasn't until we wrote Petri in 2013 that we really understood why TDD is good. Petri is our experiment system, A/B testing system. It's open source. You can find it on GitHub under wix/Petri. And Petri was written by one of our TDD experts, and this guy wrote it by the book, according to the Goose principles of TDD. And when we open sourced it, it was very easy to do that because the stuff that is specific to Wix's requirements was completely separate from the stuff that is generic to experimentations in production in general. And that was very easy, and that was what convinced us that TDD was good. So nowadays, this graph is a bit out of date, but nowadays we teach TDD at our academy. The Wix Academy is our training body. We recruit new people. We put them through a couple of weeks, 6 or 7 weeks of training, and then we deliver them to the teams, and everyone spends a week or 2 weeks doing TDD using Goose, which is very nice. Let's talk about the TDD lifecycle. Who's familiar with these hats? Wow, tough audience. Who's heard of Uncle Bob? Okay, Uncle Bob is a very famous proponent of TDD, and he uses the analogy of the 3 hats. When you write a test, you put on a red hat, and when you have a red hat, everything that you do has to do with writing a failing test. You do not implement anything. And then, when the test fails like you expect it to fail, you put on a green hat. And the green hat says, I'm now implementing the test, I'm making it work. And then, after you're done, you put in a blue hat, or yellow hat in some cases, which says, I'm now refactoring. And we're going to talk about that in a few minutes. But the thing about TDD is that people are very often confused how to start. How do you start a new project with TDD? What is the first test that you write? If I'm to write the system, the entire system from the outside in, and if my tests are my outside, then how do I pick the first test to write for a completely new system? How do I do that? So, well, in most systems, we have a product owner, product manager. If we're a startup, then it might be us. It might be a person whose job title is product manager, product owner. It might be someone else. It might be a customer. But someone knows what we want to build, otherwise we wouldn't be here. We sit down with that person, and we go over the requirements as we currently understand them, because we know that they're going to change later. And we enumerate and we prioritize this feature, but then we decide together about a good use case. For instance, if we're taking a library system, then a good first use case would be lending a book that only has a title to a reader that only has an email. It's a simple use case, but it still embodies the entirety of the system for making that specific use case work. And then we write an end-to-end test, a failing end-to-end test that describes this use case, and then we start implementing it. And we follow the rabbit hole. And like Alice following the rabbit hole, we might find things that we didn't expect. And if we find that, for instance, our use case is too complex for us, we need to go back to the product manager and simplify it. Maybe we didn't understand the requirements properly. Maybe the requirements have changed. So, we want to write a first failing end-to-end test. How do we do that? Well, that first failing end-to-end test is in English, or Lithuanian, or Hebrew, or whatever other language you choose, but it's in a human language. It doesn't talk about databases. It doesn't talk about HTTP. It talks about the semantics of the system. It makes no assumptions whatsoever about the implementation of the system. And when that test fails, like you expect it to fail, and not with a cryptic error message, then you switch to the green hat, and you make it pass. How do you make it pass? You write the simplest, dumbest code possible. Really. You don't think about architecture. You don't think about design patterns. You think about making it work. And in a new system, it's going to take some time. It might take a week or 2 weeks, and that's perfectly fine, because this is time well spent. What you end up is called a walking skeleton, because although it's a very thin slice of functionality, it goes very deep. If you have a system that will require a database, it will go all the way to a database. It might not be the same database that you're going to end up with eventually. For instance, it might be an in-memory database, whereas eventually you'll end up with MySQL or something. But it doesn't matter, because the building blocks are there. And this is time that if you do not spend it now on integration, you will spend it later, a few months in integrating stuff, and in many cases, things will not integrate. And then we'll spend tenfold the time on making changes, on bug reports, on regressions, whatnot. Now, if we're later in development stage, we've written some tests, they failed, we implemented them, we might have some copy-paste work to do. This is perfectly fine. Repeat, copy-paste is perfectly fine, as long as you're wearing the green hat. One of the biggest mistakes people make is extracting stuff prematurely. Introducing premature indirections is a very big problem in software engineering, and it often ends up creating bad design. You only extract stuff when we have evidence that it's the stuff that we need to extract. So, dry is nice, but don't be too dry. Dry is do not repeat yourself. Yeah? So, I have a failing test. I made it pass. Now, I'm putting on the blue hat, or yellow. And now I'm refactoring. And when we're refactoring, we are trying to achieve solutions to code smells. Now, these might be smells that we've introduced by naively implementing code. We might have copy-pasted and caused bad duplications. Now is the time to fix that. Now is the time to introduce design patterns, for instance. And then we go back. We write another failing test. We make it pass. And so on and so forth. But what is refactoring anyway? We've used this term for a long time. I've used this term for a long time. I didn't understand what it means. Luckily, someone wrote a book about that. And Martin Fowler, who wrote the book, wonderful book by the way, really recommend it. A lot of stuff there is specific to object orientation and Java and whatnot, but the first few chapters are just wonderful, and I really recommend for all of you to read it. But anyway, Martin Fowler said that refactoring is changing the implementation of software rather than its behavior. In other words, it's changing the design of a system after the system has been written. And it's really important because often we do not refactor. Why? Because we don't have time, because the CEO sits next to us and says deliver, because we have a meeting with the investors, because I'm going to do it next week. No, you won't. If you will not refactor now, you will never go back and refactor your software. And the tragedy is that nowadays it's perfectly possible to write software that takes a failing test and make it pass, but you could never write software that refactors properly, because refactoring requires some sort of intuition. Refactoring requires a human being. So you could say, and even more importantly, refactoring is where emergent design happens, because in refactoring is where we actually take code that we've written naively and we make it into a working design, something that is elegant. So if our job is to introduce abstractions, and if refactoring is where these abstractions actually happen, then refactoring is our job. Refactoring is the most important part of our jobs as software engineers. And if we do not do this refactoring, we're not doing our job. It is refactoring that helps us detect the missing abstractions in software. As you improve as a practitioner of TDD, you will find that your coding cycles become shorter and shorter, and it becomes easier for you to keep that discipline. And you will no longer find yourself, fighting your own instincts to overly design, overcomplicate stuff. And it will become easier for you to detect code smells, because if your code cycles are very short, if each iteration adds a very small piece of functionality, then you start with something that is perfectly fine, and then you add a failing test, and then you naively make it pass. You've added some ugly stuff, you've added a code smell. It's the only code smell in the system. So it will be very easy for you to detect it and get rid of it. And so you develop a routine of test, code, refactor, test, code, refactor, test, code, refactor. And if you practice meditation or martial arts or yoga, you might detect a similarity here because TDD has a meditative quality. And it is this meditative quality that helps you cultivate a beginner's mind. Because you focus on the short cycles, you focus on the routine, on the discipline, and it really helps you to not focus on showing off, on fireworks, on technology, on using that JavaScript framework that was released just last week. How cool is that? Meh. It's much more important to deliver software that you can maintain. So it's that feeling, it's that routine that helps you cultivate a beginner's mind. Okay, so let's wrap it up. As engineers, we have experience. Our experience is good, but it's also bad. It makes us vulnerable to repeating ourselves, to sticking with the familiar patterns, to over-engineering, to violating the Agni principle. And these prevent us from creating the proper abstractions in our software. Outside-in development is what helps us get rid of that. And TDD is a very good way to stick to outside-in development. Yeah, that's what I had to say. If there are any questions, I think we have 3 minutes or something.
Yeah, we have time for questions.
Yeah.
In your background phase, if you always have a convention, for example, that you put your database code in the model, basically in HTML, for example, that you do there, shouldn't you, when you're wearing the green hat, already put it there? Or should you just make it work and then reflect inside it, just to keep that working?
So I think the question was if I'm naively putting stuff that has to do with the model, with the stuff that has to do with the view, and then in refactoring I move it elsewhere, isn't it rework? Well, you could think of it as rework, but I think of it as a routine, as a methodology, because if you initially put it in someplace else, you've just introduced any direction. Now that indirection might be proper, but it might not be proper, and you don't have any evidence now that this indirection is needed. So it's better to not introduce an indirection until you have evidence that you need it. So the mere act of doing naive stuff, of doing stuff that seems to us wrong, prevents us from introducing these premature indirections. Yeah. Does that answer your question?
In theory, can it be done like three hats wearing three different people?
Uh,
One like that's another one like
so the question was, in theory, could you have 3 people wearing the 3 different hats? Um, well, don't know about 3, but you could have 2 people. Pair programming is a way to do that. Often in pair programming, you would have one part of the pair, one member of the pair writing a test, then the other member of the test making it work and refactoring and writing the next test, and then switch again. So everyone does everything, but not at the same time. I think the concept of software tester as its own profession in a system that is TDD'd is less relevant. If this is where you're aiming at, then to me, software testing as a profession is something that eventually is going to evolve and merge with development, with writing production code. It's very similar to what Noam said, I think, in the first talk about breaking the walls between software developers, like coders and testers. These concepts, these roles, they go back 30, 40 years, and they might not be relevant anymore, at least in the same understanding that we had about them.
But still, it's like kind of a proven fact that you cannot cover everything with like such thing as a tester, you like automate test and then you write code, right? So, and you still have to do some bug fixing. What in this case, you cannot cover them with tests. So, like, how do you approach that? Do you like only consider like write code and that's it, and refactory code? Is there like such a thing?
So, for instance, if of course I'm not going to cover everything because I don't. Again, like TDD or software tests in general don't prove that you don't have bugs. They only might demonstrate the existing bugs and their solutions. So you have a system, you have a bug. What do? You write a test to reproduce the bug. And you write the test in the innermost layer of the system where it's still feasible to do that. For instance, I might write an end-to-end test that reproduces the bug, and I might write an integration test if I understand generally where in the system this bug sits. And then I'm going to fix the bug, thus making the test pass. And then I'm going to refactor. In this refactoring phase, I might take a general test, for instance, an end-to-end test, and now that I've understood what the bug is, I might be able to hone in and move the test to an inner layer, for instance, convert it from an end-to-end test or an integration test to a unit test that exemplifies this specific bug and prevents any regression of it from ever recurring. So TDD sits very well with solving bugs. TDD does not aim at preventing bugs. Actually, and I haven't mentioned it I think today, TDD is not about tests. TDD is about emergent design. It's about writing maintainable systems. Maintainable for a long time. Yeah?
Martin the slide mentions that says that you should name things untitled chapters like book service and librarian, and you can't neglect the fact that you should make that you should name things in the way where the world points. So doesn't it not be an extremely important feature of design having that the new developer isn't familiar with their code base and can't see the patterns. If you keep naming things following the design factors like service factors and so on and so on, you have patterns in your code base, and therefore then it's easier for a new developer to learn your code base.
Okay, so if I rephrase the question, if I'm calling stuff librarian or whatever by the role and not by a pattern, doesn't it make it harder for a new developer that enters the code base to understand what happens because I'm no longer following the pattern? Well, my opinion is that no, because you are following the pattern, you're just following a different pattern. I think that the pattern of calling full service, full DAO, is very cargo cult in essence. It focuses on the wrong thing. It focuses on how things are implemented and not about what they do. As a new coder, if you go into a system and you find a librarian, you will have a pretty good idea of what it does because you know in the real world what a librarian does. On the other hand, if you encounter a book service, do you know what it does just by reading the name? Well, yeah, it deals with books. Good. What does it do with books? You will have a book service in Amazon, in a library, in a system that burns book. You also have a book service. If I had a Fahrenheit 451 system, I will also have a book service. But do they do the same thing? No. So it's all about how you look at the maintainability of a system. I don't care if it takes a new developer a week or two to understand how the system works, because after that, she's no longer a new developer, and she will work at my company for 2, 3, 4 years. Most of the duration of her employment will be about maintaining this code, not about learning this code. So readability is more important than similarity, to me. Your mileage may vary. Do you have more time?
Yeah.
Okay, yeah.
There's also a question from developers. If you have big system with really a lot of home maintenance never done, how do they start? If we get a new
I'm not sure if I understood the question. Are you talking about new developers in the company?
No. About all developers, but they say there's all products, there's a lot of
Yeah.
maintenance, it's hard to maintain.
So what do you do? How do you start TDD in an old project? How do you start doing TDD in a legacy project? Is that a question? Okay, it's a very common question. You can Google it. Actually, you Google your question, you will find a lot of different opinions. I talked about it when I talked about the public server. It was a legacy system. It had 3,000 lines of code. You couldn't understand what it does. So someone in the company is a domain expert of that system, probably. Maybe it's the customer, maybe it's the product owner, maybe it's the QA team lead who's done repeatedly tests for this system for the past 5 years, so they know exactly what it does. So you sit with that person and you write acceptance tests that take their knowledge of the system and translate it into runnable executable code. And then you run this suite and you see that it passes properly. You make it fail just to see that it fails properly. And then you can start refactoring because you have a safety net, you have a regression suite. And then as you carve into the system, you introduce more and more finely grained tests, like integration tests and unit tests that help you with TDD. So you start with test after, but just as soon as you have enough safety, enough confidence, you can start doing test first. You write a test for a new submodule and then you move logic to that new submodule, you make sure that it works, and then you switch the flow, the production flow from the old submodule to the new submodule, for instance. You could use a lot of continuous delivery techniques like feature toggles, feature flags here, but that's outside the scope of my talk. Basically, yes, you have one suite of tests, and then you start carving in, and you evolve the tests. Tests and code are not something static. They evolve usually at the same time. Software evolves, software grows. This is why I'm talking about software like a garden and not like a bridge, because it changes over time. Even legacy systems change over time. It's only that they usually change in unexpected ways and become unmaintainable.
So I think we should finish. Thank you very much, Shai, for your presentation. And please leave feedback by pressing the colorful